Welcome, everyone. This is Dr. Mercola helping you take control of your health. And today we're joined again with Ronnie Cummins, who is the founder of the Organic Consumers Association, commonly known as OCA, and been a longtime partner of ours. And he's written a new book, Grassroots Rising. And there's a long subtitle to it. Let him explain. But he's here to talk to us about that book and really inspire us to action and catalyze our efforts to some very important initiatives. So welcome and thank you for joining us today, Ronnie.
Good to be with you again.
All right. So what inspired you to write this book?
Well, the last book I wrote was on genetically engineered food and farming. And so this is along the same lines. Much of the book talks about how we need to transform our food and farming system, not only in the United States, but worldwide, if we're going to solve a lot of these problems that we're seeing, the environmental pollution, the health problems, the climate crisis, the fact that we have so much poverty in rural areas across the world, including in the United States. And so what I talk about here is the next stage of organic food and farming, which we're calling regenerative. So regenerative organic food and farming and the way we use the land, including forestry, can really solve a lot of these problems that we have that on the surface people are attributing to other factors.
Yes, the initial efforts in genetically engineered foods was really created. One of their primary arguments was that it was going to solve world hunger. We know that it's just the absolute opposite. But what you're proposing here is indeed a solution to providing plentiful food for the bulk of the world. In fact, you can expand on the premise, not the premise, but the observation that the vast majority of the food created in this world is created by small farmers, not these giant mega corporations.
That's exactly right. And you know, the way that we have traditionally grown food for the last 10,000 years, and the way we've raised animals the last 20 or 30,000 years is really organic and pasture-based. And this wild experiment that industry unleashed on us since the Second World War, using toxic chemicals and synthetic fertilizers and genetically engineered seeds and animal factory farms has proven to be a disaster, and not just for the farmers and the animals and the land, but our public health has suffered considerably. And so part of our long-term call to, as you have put it so well, take charge of your health, take charge of your diet. We can take charge of our environment and really our whole economic system if we will transform this degenerative food and farming and land use system we have now into one that is organic and regenerative.
So what do you think some of the first best steps are for the average person watching this?
Well, in my book, I talk about how there's four major drivers of a system, in this case, the degenerative system we have, or the new system we'd like to have, regenerative. The first and most important part is education and awareness. What you do so well with Mercola.com and what OCA strives to do with organicconsumers.org and regenerationinternational.org is educate the people, a mass of people. And I think we're succeeding in that. The market for organic food and pasture-raised food, regeneratively produced food and products in the United States is somewhere around $50 to $100 billion. This is still just, part, but it's happening. So this education is number one, but it's not enough to be aware. We need to practice what we preach, so that every time we pull out our wallet, we're thinking about, is this going to be a regenerative purchase that's going to benefit our health and the environment, or is it degenerative? So we got to act out our beliefs in the marketplace and create the change. The second thing we're seeing is it's innovation of farmers, innovation of ranchers, innovation of people who take care of our forests and wetlands, and people who are innovative like Mercola.com in terms of educating the public. We need these kind of innovations that we have, but we also need these to be highlighted, spotlighted, scaled up. The third thing we need is hopefully policy change, all the way from our local school boards and park districts to the White House. Right now, we have policy change. We have policy that favors big corporate special interests like Monsanto, Dow, DuPont, Big Pharma, Wall Street, and so on. If we have policies that support organic and regenerative and natural health, obviously we're going to be able to scale them up faster. And the fourth thing we need in order to scale up best practices is money. And this is private money that investors can invest, but it's also public money, our savings accounts, our retirement plans, our pensions. And there's a myth going around that we don't have enough money to have a green world, to have the kind of world that we would all like to live in, where everyone can eat organic food, where everyone has access to natural health practices, where we can swim in our lakes and rivers and enjoy nature and not have an epidemic of chronic disease and mental health problems, physical health problems. So education, innovation, policy, and investment are the four things that will drive and that are already driving this this change of paradigm. It's just that as we're noticing, we're not moving quickly enough in that direction. And so I wrote the book to inspire people to be hopeful instead of pessimistic, to look around us at the positive examples of regeneration that already exist, and to encourage us to get together with our friends and neighbors and families and coworkers and people who think like us to push this change more rapidly, because obviously we are still in a degenerative phase, but we can move out of this. And I think this year, 2020, is going to be the beginning of a pretty enormous global awakening.
Well, good. So as we're recording this, it's January of 2020, and obviously the middle of winter for most, but your primary base is in Minnesota, northern Minnesota. So you are now in San Miguel in Mexico, which is quite a contrast to northern Minnesota. But down there in San Miguel, it's a bit of an arid environment, but you've created a regenerative agricultural system that has integrated some of these practices, such as regenerative farming practices and integrating poultry and into the system. And so why don't you describe the extent to what how you're applying these principles in your own farm?
Yes. Well, as part of a global regeneration movement, we're constantly have our eyes open to see if we can find a better way to do things, best practices, we call it. And we're especially looking at best practices that can be scaled up, not just on one farm or 10 farms or 1,000 farms, but millions. And so we have been, for 10 years, running a research and teaching farm outside of San Miguel de Allende, and right smack in the middle of Mexico. It's the high desert area. It's an area, we get about 20 inches of rain a year, which sounds like pretty good. That's about what London, England gets. The problem is we get all this 20 inches over the space of 4 months, and we don't get any rain the other 8 months. And we get very intense sunlight, and we're high elevation. So it's a difficult place. But if you look at the statistics, 40% of the world's surface is characterized as semi-arid or arid. And that's the type of area we're in here. So it's not unusual for the global landscape, but it is in the United States, only West Texas and the Southwest looks like it does down here. But what's difficult as a farmer or a rancher, if you live in the semi-arid or arid parts of the world, is not only that your rainfall is seasonal and you don't get a whole lot of it, but that it is almost impossible to raise crops on a lot of this terrain. And so what people have done for thousands of years is graze livestock on these degraded semi-arid, arid lands. The problem is that they have been overgrazed, much of this 40% of the world's surface. So about 6 months ago, we were holding a workshop at the research farm here, V Organica, and it was on compost, organic compost, and how to make the best compost you can get. And we were teaching about Dr. David Johnson from New Mexico State University in the US, who we've discovered seems to be making some of the best compost tea in the whole world. So we were teaching about that. And then after the workshop, this farmer, he's probably 60 years old, he came up to me and he said, we've come up with a system about an hour and a half from here that we think would interest you. We are using common desert plants, the agave, which would look like a cactus. It's a type of cactus to most people. And these trees that you see growing in places like Texas or New Mexico, Arizona, but they're very prevalent down here, mesquite trees. He said, we've figured out a way to closely intercrop agave plants with the mesquite trees so that we can produce the world's cheapest animal forage or fodder. And it's very nutritious. And these are plants that don't require any irrigation. And meanwhile, the photosynthesis of these plants is among the highest in the entire world for the agave. So it sequesters enormous amounts of carbon while it's producing the world's cheapest, most nutritious feed supplement and restoring the earth. And I said, wow. I said, when can I come and visit your farm? We set up a date within a week. We brought a group and watched his sheep and goats eat this fermented, chopped up agave and mesquite pods like it was candy. And it was amazing. And it cost 5 cents a kilo to make this, or 2.2 pounds. So we said, well, why are you the first one to figure this out? Well, it comes down to fermentation. Just like natural health advocates and nutritionists have rediscovered the ancient tradition of how good fermented foods are for us, what they discovered was these big agave plants, if you try to chop them up, the leaves of them, or they call them pencas in Spanish, the enormous leaves, you try to chop those up and feed them to an animal, the animal doesn't really want to eat those because apparently they have saponins and lectins at pretty high levels in them. Now, these are things that the plant evolved to have these compounds, because they don't want animals eating their leaves until they get to the seed formation period of their life, 10 years or so into it. But what these farmers, and it turns out they were retired college professors too. I mean, that's partly why they were able to figure this out. One of them was an expert on the mesquite tree, which doesn't look that impressive when you see these mesquite trees. I'm sure we've all seen them when we were in West Texas or in the Southwest, the desert. They're kind of shrubby looking. They have these bean pods that come out in April, May, June. Look like string beans almost, bean trees. But these trees have one enormous important factor. They they put nitrogen, they fix nitrogen into the soil. And Mother Nature, again, why are there always mesquite or other acacia trees growing where agaves grow around the world in these degraded dryland landscapes? Well, it's nature's way of trying to repair eroded semi-arid lands, that these trees proliferate. And they don't look that impressive above ground until they get, it takes 20, 30 years for a mesquite tree to be quite sizable. But their roots, if we could see them, we would be very impressed, because their roots are going down 100, 125 feet. And what their roots are doing is fixing nitrogen from the atmosphere that the trees breathe in, and they're reaching out for all these minerals that are deep in the ground in semi-arid areas. Well, so if you have those growing in an environment with the agave grows and adds huge amounts of biomass every year, and so it's pulling nitrogen and other minerals from the ground in order to grow that fast. But if it's growing next to a nitrogen fixing tree, you've got a biodiverse system that will go on and on and on. And so the bottom line is what really grows in desert and semi-desert areas are these types of trees and these types of agave or cactus. But we never knew that these agaves could be a source of animal feed, because unless they're fermented, these saponins and lectins are nearly indigestible for animals, and they won't eat them unless they're starving. Okay, so these guys.
Well, let's stop there. How do you ferment the agave and the mesquite? What's the recipe? Because it's intriguing.
Yes, you take the agave has very large leaves. Some of them weigh 40 to 80 pounds, one leaf. They're giant. They're giant trees. So you take the lower to the ground leaves, the older growth, you simply saw it off or chop it off with a machete. Okay, you've got a big leaf that then you could chop it up with a machete, but you can't get it very fine. Well, these guys, Juan Frias in particular, invented a machine, simple machine, that will chop up this very tough leaf into, looks like green coleslaw when it comes out of the machine. And this machine is pretty darn simple. It costs $5,000. We bought one right away. One machine will service, 5 or 10 communities. And so it comes out like coleslaw. Okay, if you bring your cow over there or your horse to eat some of this, it looks a little more appealing now as the green coleslaw. They won't eat it. They can smell that's got some stuff that might be good for making soap, like saponins, but they're not very tasty, and they're not going to feel very good when you eat them. So they don't want to have anything to do with that. But what you do then is you put it into a container. We use these 5-gallon buckets with a lid, sort of like wallpaper paste. Right? Yeah. And you put this green coleslaw, you shovel it into one of these, and then you, when it's halfway full, tamp it down we're using 4x4s, a crude method, but you're trying to get the oxygen out. Once you've tamped down the half, you fill it up, you tamp down that, you put the lid on. You put this aside. In 30 days, it will ferment, and then when you do a lab test, these saponins and lectins have been transformed into sugars and carbohydrates that it also turns it's a gold color. And so it'll last for 2 years.
Wow. So you don't have to inoculate it. They're just using the indigenous bacteria that are already on the plant?
Yeah. It's got so much sugar in it that in the anaerobic or semi-anaerobic environment, it goes crazy with that 30% sugar and really begins to ferment. In fact, after a couple of days, when we put the lids on, we started getting a little alarmed because we could see the methane actually coming through the closed lid on the sides. And we said, oh my goodness, we just filled 1,500 of these. Are we going to have a giant explosion that's going to blow the roof of the shed off or what? But we learned.
Is it methane or CO2?
I think that's methane coming out.
Methane? Okay.
I'm not positive, but that's what someone told me. But we learned, don't stack these 5-gallon buckets on top of one another for the first 30 days. Just have them, because you don't want that added pressure. But lo and behold, after 30 days, we started, because the original farm, the only farm in the world that's doing this on a scale right now, they only feed it to their sheep and their goats because that's what they raise. But I asked the scientists right away. I said, "What about pigs? What about chickens? What about horses? What about cows? Some of the other animals that we have?" They said, "Well, we don't know, but we assume they will react similarly." And so we said, "All right, well, we're going to try it out." So we immediately put it out for our chickens because we've got several thousand chickens in an outdoor, and they loved it immediately. They were all coming around eating it. Then we fed it to our pigs. We've got some of these Duroc, they're a dark-skinned pig that does well with being pasture raised and, with a hot sun. They do a lot better than the white-skinned pigs. They were rolling around in it, loving it, and so we've advanced a little further. We've found out now that you can feed pigs up to 50% of their diet can be this fermented agave, and that the chickens were around 20-30% of their rations now are this, and with the sheep and the goats, in some of the trial areas, up to 80% of the ration. So the importance of this is, first of all, if you're a small farmer, you can't afford alfalfa and you can't afford hay during the dry season, and it's too expensive. We can't afford our chicken feed that we have for our organic free-range chickens. We can't afford it in the sense that it makes our eggs and our meat too expensive in the marketplace for people to buy. But when you start looking at, oh my God, what if I could reduce my feed costs by 50% or even 3/4 with this stuff that costs a nickel or a dime, and then I wouldn't have to overgraze my animals. They'd still graze because it's good for them. They get a lot from that grass that they really need, but you wouldn't have to have them outdoors every day, overgrazing on pastures that are not in good shape. So this is pretty amazing stuff. And then what we found is that if you do a lab analysis of just the fermented agave, it's about 9%, I think, protein, which is, it's pretty good, but alfalfa is more like 16, 18%. So what these farmers, who are also retired scientists, figured out is if you put 12% of the mix in your fermentation, if it's the pods of the mesquite trees, the bean trees that I described, it'll shoot the protein level up to about 18. And that is it's about the same as alfalfa. But as these scientists have pointed out, there's a lot of other things in this too that make it better than alfalfa. So one of the things about alfalfa, especially in dry land areas, this 40% of the world, it's like it is around here, is alfalfa takes a lot of water. You have to irrigate it in the dry season and just in general. The agave plant uses 1/26 the amount of water to produce a gram of biomass as alfalfa. In other words, these desert plants have evolved over millions of years to utilize water and moisture in a really efficient way. And they're called a CAM plant. There's 3 different kind of plants in the world, the C3, the C4s, basically grasses, crops, and these CAM, these desert plants, which the difference with the desert plants is their leaves, the opening in the leaves, which is called a stomata, on the bottom of their leaf, even these giant agaves, it does not open during daylight hours. Mm-hmm. It only opens at night after sunset. And these plants literally suck the moisture out of the air all night long. And then when daybreak comes, the stomata closes up. And what that means is that during the day, you don't have the kind of evaporation of water that you would have from a pasture grass or a crop. And so these plants are enormously adept at saving water in their leaves, in their pencas. They can go years with no rain, and they can survive pretty harsh temperatures. They can survive as long as it doesn't get colder than 14 degrees Fahrenheit. They're fine. I mean, that means they don't grow except in southern parts of the U.S. But they can survive 135 degree Fahrenheit temperatures and little or no rain, and they require no irrigation. And so this is pretty amazing. And I mean, why were we able to discover this? Well, it's because we were on the lookout for best practices. One of those, farmer innovation is really the key out there. Everything we need to know to get even beyond organic, someone's already doing it. And chances are someone's doing it right in your region. You just haven't heard about it. So the other factor, we're trying to educate people now, because typically agaves and mesquite are considered to be worthless nuisance plants, except for
One clarification. The only part of the mesquite you're using is the bean pod, not the bark or the wood part, right?
Oh, well, you use those too when they grow up. One of the things you can do, these scientists have figured out, is if you prune part of the branch as well as the bean pod, that actually that branch has a lot of good nutrients and protein in it. And it's a hell of a lot easier to prune part of the branch than it is to just pick off these things have nasty thorns.
Yeah,
they've invented a machine also that chops up the branches and the thorns and also hammers it's called a hammer mill. It hammers the seeds, because the seeds are extremely hard in these mesquite trees. Again, that's an evolutionary thing, because Mother Nature does not want the animals to eat the seeds and digest them. They want the animals to eat the seeds, have their digestive system take off part of the coating, and then poop them out. And you see the trees are growing out of the animal manure. So, but if you can crush the seeds, you got some really nutritious material in there. So this combination.
This is a separate machine. So you got 2 machines: a shredder for the agave, and then the hammer mill for the mesquite.
Yeah, and you simply put the mesquite, in there at the last. And it doesn't have to be a mesquite. Any of these nitrogen-fixing trees that are common in drylands areas. In Africa, for example, they're called acacia, the variety. They're all over the place in the poorest, most degraded landscapes. In a place like Australia, Lucana is a type of fast-growing nitrogen-fixing fodder tree for livestock. Huisache, they have different names around the world, but the common thing are that these are the neglected trees that you find in dry land areas that are not suitable for raising crops. And so the enormous potential, and then I looked up the literature, the scientific literature on this, and I found that agaves in the whole world, there are 4 trees that have this rapid photosynthesis that sequesters so much carbon from the atmosphere. It is Japanese cypress, Monterey pine, African palm oil, and what's the fourth? I forget the fourth here for a moment, but the agave is right in there, sequestering 40 tons of carbon. That's not CO2, that's carbon. Multiply that by 3.67 to get the CO2 per 2.5 acres per year. So these things grow so fast. One scientist in India has said, what bamboo is to the areas of the world that get a lot of rain, agave is to the dry lands.
Wow.
And so the enormous importance of this is that the 40% of the world that is the semi-arid, arid lands, these are the poorest people in the world. These are also the soils that are the poorest, that have the least carbon. You know, the world soils used to have between 3 and 7% carbon organic matter in them. You know, the world average now is around 1%. This is literally the key to climate stability, is to get that carbon dioxide that used to be in the soils and the trees and the plants, get it out of the atmosphere, get it back where it belongs, where it'll make rainfall infiltrate into the soil better, where it makes the soil more fertile, so that the grasses you're growing or the whatever you're growing, the trees, the crops will be more nutritious.
So you've given an excellent prescription for remediating the land in these arid conditions. And I'm wondering, you've got a variety of different animals, chickens for certain, and if you could relate how that project is going, if you're integrating some of the holistic herd management that Allan Savory teaches, and are you an Allan Savory hub down there? Or?
We're not right at our farm, but it's the same principles. I mean, essentially, holistic management, what they produce is grass, for the animals, and they do it in a really good way, restoring the environment. And this system, yes, we're grazing animals in there too, in between the agaves and the mesquite trees. But in addition to grass, what we're growing are these this feed supplement, this fermented forage. And so the importance partly of all the system is there's not one chemical required in this whole process. This whole process is inherently organic. That's incredibly important because, like lamb burgers. I know in the U.S. lamb burgers are, they're really tasty. They're very nutritious, but they're $12 a pound in Whole Foods. They're $10 a pound at my co-op in Minneapolis. Believe me, these type of farmers are getting less than $1 a pound right now for their sheep and for their mutton, for their lamb, for their mutton. So we're just today, we've got an organic certifier out looking at one of these operations. We're going to get organics out of all this. So the chicken, instead of us spending 45 cents a kilo for our chicken concentrate, which is what organic feed for chickens costs now. Like I said, this is this is 5 to 10 cents. So if you can reduce your feed bill, that portion of it by that amount, what we're going to end up with is still the best kind of eggs you can get because of our organic free range and still very healthy meat, but we'll be able to price it at a level that everyday people can afford. Uh, and so the same thing with pork, the same thing with the sheep, goats, and we have horses. We do horseback rides. Dr. Mercola has been on one of them. Our biggest expense with our horses is the alfalfa. I mean, these guys are they like to eat alfalfa.
Can't you feed them the agave, fermented agave?
Yes, we're starting to experiment with that, and our horses are a little spoiled, so you have to get them kind of used to it. It's sort of like a lot of people, they turn up their nose when they first try sauerkraut or kimchi. Mm-hmm. Yeah, but after you start to get a little used to it, you see that, oh, I like this stuff. It makes me feel good, and I like it.
Do you notice any improvements in the health of the animals if you're feeding this? Because it would seem like it would improve their microbiome.
There are substances that have shown up in the lab reports that indicate they would strengthen the immune system of the animals. There's growth factors that are natural, but this is so brand new that literally, I mean, we're seeking funds right now from the city government, state government, federal government, investors to push this a little further. We do have the basic information there. It does look like it will be of health benefit to the animals. Now, it's not, we don't want to you don't want to just coop up the animals and feed them nothing but this. You probably could. You could still fatten them up. But we know that animals grazing out there on a wide variety of grasses and forbs, they're getting things in their diet that we don't even understand, but they need. So we're continuing to graze. We're using solar fencing to where we can keep the animals away from the small seedling trees, but still have them be able to graze on the grass. And then we feed them back at we bring them in at night because we have coyotes and, some wild dogs and other things. At night, we feed them the forage, the forage. And so far, so good. And everyone is looking at how do you, like Mexico has a big program now where they're trying to reforest the country. And the problem is if you try to reforest in a climate, the climate like this, which is 60% of Mexico, the trees won't grow unless you water them, at least the first few years. Even mesquite, you do have to water it the first dry season. So they can't figure out what to do. And in fact, I've got a meeting next Monday with the national head of the reforestation program. I'm going to try to convince her to look at this technique and see if there's some interest, because we got to scale this up, and we got to scale it up pretty quickly if we're going to take care of the problems that are, driving the forced migration. I mean, the whole reason we have a immigration crisis at the U.S.-Mexico border is really it's rural poverty. If people weren't so darn poor, which leads back to if they didn't live in such dry, degraded landscapes, they wouldn't be seeking to come to the U.S. except for a visit, and so we can solve this immigration problem. We can solve this problem of rural poverty. We can solve the problem of, a lot of the small farmers, they can't even afford to eat their own animal, like the lamb on a regular basis. They have it for celebrations and so on, but they should be able to eat lamb burgers on a regular basis in the rural countryside. Right now, they can't afford to. They will be able to. And in the long run, if we restore the landscape, things like corn and beans and squash will grow again, because it's become nearly impossible to grow the traditional corn, beans, and squash in these areas because of the climate has changed. We didn't get the rainy season this year until late. We got some heavy downpours at the beginning, and then we didn't get any rain for quite a while. And we got heavy rains again. And then we didn't get our normal, we usually get a few freezes this time of year. And one of the nice things about the freeze is it kills all the grasshoppers. Well, this year we didn't get the freeze until last week. And we had more grasshoppers. It looked like, the plague had hit. These guys were in such huge numbers, eating nearly everything in sight. And they ate up our corn crop and our bean crop, which was looking pretty good. So we need to not only get the weather back to the way it used to be, but we need to have some feed for the animals in the meantime.
So are you teaching the other local farmers this technique? I mean, it seems pretty straightforward. All you need is a shredder and some 5-gallon buckets.
Yeah, we're having seminars and we're paying visits. We got Mexico has an interesting system of land ownership. This came out of the Mexican Revolution in 1910 to 1920, where they divided up most of the land in the country, and this is a pretty big country. They divided it up into these communal holdings. They call them ejidos, and there's 200 million acres of ejidos in Mexico. Over half of all the land in the country is owned by communities. The problem is most of this land looks like the land around here. It's, quote, it's degraded. There's no irrigation. It's not the best land. The descendants of the Spaniards, the people who controlled things here for a long time, tended to end up still with the best land, over the last century. The land that had wells or that had surface water, the land that got more rain and so on. So you got all these lands that are basically useless economically, that are simply being overgrazed. That's about it. And but it's interesting that we are contacting these community groups, these ejidos, and we're inviting them to come to this one community where we're doing a pilot project. And they're very interested in this. They don't believe every word we say. This sounds too good to be true in the beginning. What I've noticed is until they see the sheep and the goats gobbling this stuff down, that they always considered to just be garbage, because, I mean, traditionally these plants are of some value, agaves, because you can produce alcoholic beverages from them. Like the most famous is, there's 200 species of agaves, and one of them is called blue agave. Blue agave is what produces tequila. And so there is some understanding that these plants are valuable, but no one ever understood until recently, and just in our tiny part of the country so far, that the leaves are actually more valuable than the pineapple or the piñas that you get in year 10. And so,
do you think you can use aloe to create this? It's a similar plant, not the same.
Aloe is in the it grows in the same areas, and this is going to be one thing that we're going to plant for biodiversity purposes, because you don't want to plant just agave into these pre-existing.
But can you use it to ferment it to provide food for the animals?
I bet you that we're talking about, we want to experiment a bit with that, because the aloe grows really well here. The difference is that, as you know, the biomass of the aloe
much smaller,
is much smaller. The beauty of I've actually got one. I've got some right out here growing in my patio. These plants are enormous. I wonder if I should I show you one?
No, we can insert a graphic to show people. I've seen them in person. They are extraordinary. The average person would have a great difficulty picking up one of these leaves. I mean, if you're a bodybuilder, not an issue. but 80-pound leaf is a heavy leaf.
With 30% sugar is what's in
Yeah.
them. I mean, it's pretty amazing. Oh yeah, the other thing that's advantageous is, if you're feeding this forage to the animals, once it's fermented, a large proportion of that is liquid, like 50% or so.
Mhm.
And so the animals are getting a lot of water too while they're eating this, which is it's a big plus in a dry area like this because water is always
Yeah,
at a
and
premium.
I would almost guarantee you that water is structured water too.
Yes. Yeah, that's what they said. These scientists said if you analyze the water content of alfalfa, there's very little nutrition in it. You analyze this thing is supercharged with a whole lot of things that are good for the animals.
Yeah, that
We
is extraordinary. I wasn't anticipating that type of finding. That is
Well,
pretty
there's another
groundbreaking.
thing. When you're Steve Rye from Mercola was down here visiting, one of these scientists came up to us with a bottle of a nutritional supplement called inulin.
Inulin, sure. Yeah,
Yeah,
FOS,
yeah.
fructooligosaccharides, right?
And he said, "Yeah, Steve and me." He said, "Have you ever seen this?" And Steve said, "Yeah, we get this." Almost every nutritional supplement vitamin company gets these from Belgium from the roots of chicory
Mhm.
plants, I think.
Right.
And so Dr. Frias said, well, we get them from dehydrating the liquid in the pincus or the leaves of the agave.
Hmm.
And he said, it's these are really good. And so we're investigating this because this is just a byproduct of this entire thing because we do have more liquid than we actually need when we're doing this.
Ah,
And
what do you normally do with it? Do you put it back in the soil or?
well, when you're making the forraje, like the first stage when you're chopping it up,
Mhm.
there's some of this liquid is falling to the ground, and so but the thing is, these leaves, there's so many agave leaves that are potentially out there. Uh, there we can use some of them not for forage but for inling. And so, and the good thing about this process is that it's inherently organic as well. And we're going to go for biodynamic for every single stage of this process. In Mexico, your first stage to get biodynamic certification is to get organic. And we're talking to Oregon Till right now about certifying these processes. But it's amazing, I mean, 2 centuries ago, the British they moved agave plants all over the world to all their colonies because back then henequen, which is one of the species of agave, was used for bags and textiles and so on. It's a real strong fiber for rope and so on. And there was actually a booming industry 200 and 300 years ago in henequen. And so one good thing is that the British took these agave plants to their colonies in India and China and Africa and were growing these for textiles back then. And then once we had modern equipment for cotton processing and wool processing, the henequen kind of fell out of use. But we've had now for several hundred years these agave plants growing in, according to statistics I've read, 20% of the world has agave plants living in them. And if one agave species thrives, these others, some of these others, like the ones we have around here with the enormous biomass, will also grow. So if you're looking at, like Regeneration International, one of our staff members lives in Zimbabwe, where millions of people are facing starvation right now. But this is where Alan Savory's demonstration ranch is in Zimbabwe. They know about rotational grazing, but what they don't know about is the value of these overlooked plants that are in their environment. And so we're looking forward to, once we can prove this technique really works in Mexico, north central Mexico, we want to establish contact with all these regenerators around the world and see if they're interested in, coming here, checking it out, but also starting to think differently about these degraded lands in their countries.
Can you make compost out of that too?
We are doing that with some of the more shriveled up pancas that we don't want to put in the mix. We just noticed that it takes them a long time to decompose into compost because they're so fibrous. There's a little industry that has developed pretty interesting with agave. They're building construction blocks out of the agave because it's so strong, but it's very lightweight. So you end up with, like blocks of bricks or whatever that are very durable, that are made out of this substance. So we're going to look at when you look at Mexico is 32 states, and one of the states is Jalisco. That's where Guadalajara is, second biggest city in Mexico. But Jalisco alone, the state of Jalisco, as I speak, has 500 million blue agave plants growing right now. And they're harvesting 10% of those every year. We literally, we figured it out in this county. This is a pretty big county, San Miguel, in terms of the geographical size. We only have 181,000 people, but it's a sizable county for Mexico. We figured with 2.5 million agave plants planted over the next 10 years, that we could eliminate all the greenhouse gas emissions that the county puts out right now. And so it's going to be using land that, we'd need to do this on 30,000 acres, but these would be acreage that nothing is growing now of agricultural value, and where it's being overgrazed.
Better than planting trees.
Better, and it is a kind of the weird thing about these desert plants is like they're not defined as a tree, but I mean, if a tree is something like that's perennial and that puts out
and produces biomass, puts carbon back in the soil.
This is an agroforestry system. You should not do it except the trees together with the agaves and the grasses. You throw out pasture grass too. So that, and you also you're using some cover crops of leguminous or bean-like cover crops, so that you want to keep putting as much nitrogen and nutrients into the soil as you're taking out, so that this system, is continuous. And also because you're going to be grazing animals this.
And you want the carbon in the soil to capture the water because it's so sporadic and it comes in large amounts at the same time. And the only way you're going to capture that is to have the carbon in the soil.
That's right. And before you do any of these systems, there is a preliminary. I mean, if you're looking at degraded landscape, imagine parts of New Mexico you've seen, or West Texas or Arizona, these areas where you see these gullies that have been eroded. If you're looking at a landscape like that, which is 40% of the world's surface area, you first want to do a little ecosystem restoration on that eroded area. And what you do is pretty simple, is you find the most heavily eroded areas, they're called in English check dams. You pile rocks in these heavily eroded areas, not enough to create a dam, but almost a dam, to where when in the rainy season, the water will just flow over it. The other thing you do is, I'm sure we've all seen terracing, for agriculture around the world, where rows aren't in perfect perpendicular shapes. they're curved when there's hillsides or when there's any elevation at all. And what you do is modern days we fly a drone over the territory, over the area you're looking at, and you do aerial photography, and then you can send that data into a processing lab, which will give you back the information. They'll tell you things like, here's the percentage of this 100 acres that's covered with trees. Here's the points where you need to have these what's called key line contours. So you do contour lines, you pile rocks that are around there on these contour lines, and then you plant your agaves and other trees along these contour lines. And what all this does is it means that during the rainy season, instead of the rain coming down elevation and taking the topsoil with it and silting up creeks and rivers and whatever, it slows it down long enough to where it can penetrate into the ground, into the groundwater. This type of regenerative agriculture, Dr. Mercolas, you ran an article of mine in your newsletter recently. So the education thing is ongoing. We're finding the farmer innovation. We're starting to search for the policies that could help scale this up, because the criteria, some of these criteria for what is a tree, what is reforestation, what is carbon sequestration don't quite fit. And then we're going to be looking for the financing to scale this up, because literally this regenerative practice in dry lands is a game changer. There are practices like this in wetlands and in the global north that we're already seeing, things like holistic management of livestock and biointensive organic practices. But it's all these practices together, the best practices from the different parts of the world, different ecosystems, that are going to make a difference. But it's you, the consumer, it's you, the reader, that we need to spread these good news messages. And I hope you'll consider buying a copy of my new book, Grassroots Rising by Ronnie Cummins, where I try to paint a roadmap of how we can regenerate the world's landscapes as quickly as possible so that we can get back to enjoying life.
Yes, indeed. So, and you're not hypocritical either. You're actually doing what you advocate in the book, and you just shared with us a really very fascinating application of the strategies you're integrating down on your farm, and pretty novel, and I think can have pretty significant impact for the 40% of the similar climates that are out there in the world that are really hard to manage and generate biomass and crops to sustain the farmers there. So I'm really excited about the innovation you've found and are starting to implement. It's really good to see and good to catch up with you.
Good to catch up with you. I look forward to seeing you in Florida in a couple of weeks.
All right.